All right, back to the good stuff. I'm not sure how long I can go, but I could probably do a half an hour here. So back to good stuff. Python for DevOps. Following the numbers with that, got a lot of great views and stuff with that. So um, now I'm having a bit of a problem here because in order to move on with the book, and this yeah, so this is an older location. This is basically where I left off. I have to go back and do some examples. So, like for example, the URL shortener CDK example um, is one of the things I need to have up and working, and I've spent a lot of time on that, and it hasn't really worked out. Let's see here. Okay. I've got it to the point where I can run the SDK deploy. Now let's see if there's like a help so I can see. Let's do a dash VVV. There we go. So now we can see everything. Hopefully we can't see my account ID. But oh, you know what? I'm in the wrong. Uh, hmm. So I need to be in Python. I need to be in a different present working directory. So the one I need to be in is in the description of the video. So if I go to my channel and I go to the prior video I did, which is that's what's
All
so great
right.
about making these videos. I have everything lined up. You know what? It's in the book. It's in the book. So where is it in the book? It's right here. Okay, so I need to be in Python and then URL shortener. All right, and now I can run it. I might do a quick off camera just to make sure. Do it a once over. All right, I'm back. You'll just have to take my word for it because it does show like account information when I run that with the verbose output. It ended in a error. There was something about like authentication. It couldn't authenticate to my account. So I've done this many times before as part of these series. I think it's fair game to do. I'm gonna take the L on the example and move on. I've done that plenty of times before, and I wish I could get everything working perfectly, but I just feel like it's not as useful to just you know to stop to just completely stop. So it looks like there's quite a bit of actual code coming up. So yeah, so I'm gonna remove this older bookmark here and then just start. So the previous command created 5 Lambda functions, 1 API gateway, and 1 Dynamo DB table. I'm pretty sure they would charge for this on AWS. In the CDK directory, add a DynamoDB table to the stack we are building. So if we do a pwd, there we go, and then now hopefully, so this is under code, serverless, CDK, Lambda. What do I got here? CDK examples. I don't even think I have the right repository pulled down. It's just a complete mess. Install the required modules. So I know how to do that. I did get it running. It's just it was not able to authenticate to AWS and create the resources I need, which is probably good because it might have charged me if it were able to do that. So inspect the CloudFormation stack that will be created by running cdk synth. There we go. And pass a variable called variable containing the region value to the constructor. There we go. Run CDK synth again. It doesn't really work for me, so I'm not going to do that. Deploy the CDK stack by running CDK deploy. And remember, this is just doing it in the CLI. You can do this all in the GUI as well, so that might be a better way to do it. It's just I'm really kind of paranoid about, because I'm putting things out publicly on the internet, I'm kind of paranoid about my AWS account because it's just so sometimes tricky to know like how much you'll get charged and stuff. Like they have great tools for figuring it out, but I'm just really worried that $1 million will be run out on my account. You know, it's like if somebody hacks it, they might do so they can run up a lot of charges. All right, so the next step is to add Lambda functions and the API gateway resource to the stack. In the CDK code directory, create a Lambda directory and copy the Python modules from the serverless platform AWS REST API example. We could look at that example. So here's the example here. I guess there's no README, so I'm a bit concerned. If I go back here, oh, there we go. So here's the README. So serverless, okay, perfect. Looks good. Okay, looks good. Serverless deploy. Serverless created to do. Yeah, so I'm gonna skip over that. Add the required modules using pip. Know how to do that. Create Lambda and API gateway constructs in the stack module. All right. So lots of the code here. This is the CDK. You can do this in the GUI as well. I'm just gonna do kind of what I've done in the past, which is just move on and keep reading and give it a good college try to get it working. But if I can't, then not put the entire series on hold and just keep going forward. So it is worth noting several features of the code we just reviewed. We were able to use the add environment method on each handler object to pass the environment variable DynamoDB table used in the Python code for the Lambda functions and set it to table.tablename. The name of the DynamoDB table is not known at construction time. So the CDK will replace it with a token and will set the token to the correct name of the table when it deploys the stack. See tokens documentation for more details. We made full use of a simple programming language construct, the for loop, when we iterated over the list of all Lambda handlers. While this may seem natural, it is still worth pointing out because loops and variable passing are features that are awkwardly implemented, if at all, in YAML-based infrastructure as code tools such as Terraform. So that's good to know. I do agree with that. And even in like Jinja, I think using a for loop in Python is better than using it elsewhere. We defined the HTTP methods get, post, put, delete associated with various endpoints of the API gateway and associated the correct Lambda function with each of them. So deploy the stack with CDK deploy. Tried that, not working. Oh, we've got an error here as well. The stack uses assets, so the tool stack must be deployed to the environment. So we can fix that error by running CDK bootstrap. I wonder if that will work for me if I try that. Let me try that. So I'll pause it because I don't want my account information to go on, and I have to change the temperature in here. It's getting pretty hot, so I'll be back shortly. All right, I'm back. It was actually only 2 degrees hotter in here than normal, so I'm not sure why I'm feeling so hot right now. But the so the results from CDK Bootstrap were similar as when I did CDK deploy. I got this error saying something about not having any credentials configured. Now, I withheld my account ID, so I feel comfortable showing this. So I'm going to paste this in and have a chat with GPT. Hopefully I get to the bottom of whether or not this will cost me anything. And if it doesn't, then, hey, I might be able to get the example to work.
The error message you're encountering indicates that the AWS CDK Cloud Development Kit is trying to bootstrap an environment in your AWS account but cannot find the necessary AWS credentials to make calls to AWS services. Bootstrapping is a process that prepares your AWS account to work with the CDK by deploying a CDK toolkit stack into an AWS environment, which includes resources like an S3 bucket for storing files and IAM roles that CDK needs to deploy your stacks. To resolve this issue, you need to configure your AWS credentials on the machine where you're running the CDK commands. Here are the steps to do that. Install AWS CLI. If you haven't already, make sure that the AWS command line interface, CLI, is installed on your machine. You can download it from the official AWS CLI page. Configure AWS CLI. Run the configure command to set up your credentials. You will be prompted to enter your AWS access key ID, secret access key, AWS region, and output format. These credentials are used by the AWS CLI and other tools like AWS CDK to make calls to AWS services. Enter your AWS access key ID and secret access key when prompted. These can be obtained from the AWS Management Console under Security Credentials. For region, you can enter a CS1 or any other region you're working with. The output format can be left as default or set to JSON. Verify configuration. After configuring your credentials, you can verify if they are correctly set up by running a simple AWS CLI command, such as s3ls, to list the S3 buckets in your account. If you see a list of buckets, or at least don't get a credentials error, your setup is correct. Redrive.
All right, so the answer is clear. I need to set up my account authentication. I did not do that. So kind of like how you upload a key in GitHub to be able to make pushes and pulls, you have to do an authentication step in AWS as well if you're using CDK. So it looks like you have to install the AWS CLI in order to do those authentication steps. So let's see here. Okay, so we're getting started. So this looks like it's not really related to what I need to do. I did try to run AWS configure, and I'm getting a link from my package manager. You know, I'm getting a hit. So I'm gonna run this, and hopefully that's enough. Okay, so that is done. So the next step is going to be from ChatGPT, which again, oh my god, is so wonderful. I can get so far. Like my prior videos on this series, I almost want to go back and redo because ChatGPT. Well, that's the thing. You know, I've got better books to come. So I want to get this one out of the way quick. Let's see here. AWS configure. We're gonna try that. All right, so now I need to enter in some private information. So I'll pause the video, do that, and come on back. All right, so I can come back here briefly. I'm not sure how to find the information I need. I need a access key ID, secret access ID. I'm logged into my account right now, so I'm just going to be brief here. So I've got a good response from ChatGPT, even though I accidentally, I meant to copy and paste in more than just that. But it looks like I need an IAM user account, which I got. Then I go to users and then choose add user. So I need to go through a whole process. So I'll do this off camera because I don't want my account information to leak, and I'll be right back. All right, I'm back. I gave it a try. I didn't really get anywhere, so we're going to keep moving on. So deploy the stack with deploy. Fix by running this. Deploy the stack again. The next step is to test the API with curl. First create a new to-do item, then a second to-do item, Try getting the details for the item just created by specifying its ID. Navigate by inspecting the CloudWatch logs for the Lambda function. To fix, change the line in lambda/get to that. Redeploy the stack with CDK deploy. Try getting the to-do item details with curl again. Make the import decimal encoder change to all modules in the Lambda directory that need the decimal encoder module and redeploy with CDK deploy. List all to-dos and format the output with the JQ utility. Alright. Create a to-do and verify that the list does not contain it anymore. Now test updating an existing to-do item with curl. Inspecting the CloudWatch logs for the Lambda function associated with this endpoint shows this. Change the validation test in Lambda to that. Also change the value for checked to true, since we have already seen a post that we are trying to update. Redeploy the stack with CDK deploy. Test updating the to-do item with curl. List the to-do items to verify the update. Next step is to provision AWS Fargate containers that will run a load test against the REST API we just deployed. Each container will run a Docker image that uses the Taurus test automation framework to run the Molotov load testing tool. We introduced Molotov in Chapter 5, I do not remember that was 2 years ago, as a simple and very useful Python-based load testing tool. Start by creating the Docker file for running Taurus and Molotov in a directory called localhost. Okay, so this is the test, the load balancing between the Fargate containers that were deployed. I was not able to deploy the Fargate testing, so I'm gonna have to unfortunately take a loss on this as well. Can't win them all because it's dependent on the prior examples working, and I wasn't able to figure out how to create AWS free Fargate instances. So I just can't continue any further. All right, so here's what we would do if it was working. We would create a Docker file to set up a Taurus machine, Docker container that is able to test load balancing. The Docker file runs the Taurus bzt command line using the taurus.yaml configuration file. There we go. In this configuration file, the value for concurrency is set to 10, which means that we are simulating 10 concurrent users or virtual users, VUs. The executor is defined as a Molotov test based on a script called loadtest.py in the scripts directory. Here is the script, which is a Python module. So there we go. This is a Python module. There we go. The script has 4 functions decorated as scenarios to be run by Molotov. They exercise various endpoints of the CRUD REST API. The weights indicate the approximate percentage of the time of the overall test duration that each scenario will be invoked. For example, the test list to-dos function will be invoked in this example approximately 50% of the time. Test create to-do will run approximately 30% of the time, so they're kind of simulating a load that will be balanced. And test update to-do and test delete to-do will run approximately 10% of the time. So build the local Docker image. Unfortunately, this part I could probably do. I could build the Docker image. I probably even have Docker set up in my WASL, but after that I couldn't go forward. Create the local artifacts directory. Obviously, I can do that. Run the local Docker image and mount the local artifacts directory as /temp/artifacts inside the Docker container. So you should have to enter the Docker container. Yeah, so docker run -rm. If the Docker container is not already running, you can do a Docker run to get in the Docker container. If it's already running, then you need to do docker exec. Debug the Molotov script by inspecting the artifact/molotov.ou2 file. Torus results can be inspected either with Docker logs container ID or by inspecting the file artifacts/bzt.log. Results obtained by inspecting the Docker logs. So there we go. These are the results. Create CloudWatch dashboards for the Lambda duration, figure 13-1, and DynamoDB provisioned and consumed read and write capacity units. There we go. All right. The DynamoDB metrics show that we under-provisioned. The DynamoDB, because I know exactly what's going on right now. The DynamoDB read capacity units. This introduced latency, especially for the list function shown in the Lambda duration graph as the red line going to 14.7 seconds. Obviously, any idiot would know that. Which, sorry, I'm so lost. Which retrieves all to-do items from the DynamoDB table and thus is heavy on read operations. We set the value of the provisioned read capacity units to 10 when we created the DynamoDB table, and the CloudWatch graph shows it going to 25. Let's change the DynamoDB table type from provisioned to pay per request. I'm not going to do that. Make the change in the file before. So taking the L on this again. Not going to even go through and change. I could probably do this too because I probably do have the files, but the files don't run, so I'm not going to spend the extra time on that. Run cdk deploy and then run the local Docker load testing container. This time the results are much better. The graphs for Lambda duration, figure 13-3. Hopefully I can I open this in a new tab? No, I'd have to lose my spot. And DynamoDB consumed read and write capacity units. That'd be so cool if you could hover over it and see the image. Wouldn't that be awesome? And DynamoDB consumed read and write capacity units. I feel like I want to make my own reader because my reader would be awesome. In my reader, you'd be able to hover over something like this and see the image. I'm curious to look at the image, so I'm bookmarking this and I'm going to click this. There, and it takes me back to the images, so it's not so bad because you can look at the images and then you can click back here. But if you don't put that bookmark down, you're out of luck, and then you have to look at you have to flip the pages. If you could just hover over and see the graphs, that'd be so cool. All right, but they do show the graphs again, and in fact the ones was this from the prior page. We're at 4.8. I'm a little bit confused by what I'm even seeing there, but anyway, I can't get this to work anyway, so DynamoDB consumed read and write capacity units for 4, and then this is the Lambda duration, so things got better, even though it looks like things are going higher. So this is the consumed read capacity units. Consumed write is just flatlined, but read increased. Note that the DynamoDB consumed read capacity units are automatically allocated on demand by DynamoDB and are scaling up to sustain the increased number of read requests from the Lambda functions. The function that contributes the most to the read requests is the list function that is called in the list, update and delete scenarios in the Molotov loadtest.py script via session.get base URL plus /todos. Next, we will create a Fargate CDK stack that will run containers based on the Docker image created previously. So there we go, we're creating a new stack. So they're typing this out. I think this code is meant to be typed out, or like just I think this is new code for the book, but a few things to note in the code for the Fargate stack class. A new VPC is created by using the AWS_EC2.VPC CDK construct. An ECS cluster is created in the new VPC. A Fargate task definition is created based on the Docker file from the load test directory. The CDK is smart enough to build a Docker image based on this Docker file and then push it to the ECR Docker registry. An ECS service is created to run Fargate containers based on the image pushed to ECR. The desired count parameter specifies how many containers we want to run. Call the Fargate stack constructor in app.py. Alright, so we're catening out the files, see what that looks like. And then, wait. This shouldn't be cat if you're trying to call it. Okay, I'm not sure what's going on there. Next step is to deploy the CDK Fargate stack. So this is kind of what I was expecting to see. So here we got a CDK deploy command. I'm not sure what they meant by calling something. Go to the AWS console. I'm going to do an audio check because I need to. I don't know why my audio is so quiet. Go to the AWS console and inspect the ECS cluster with the running Fargate container. There we go. You know what? I can turn it up in. Let me try this. All right, I gave it a bit more juice. Maybe that will help. Okay. So there we go. It's already too late in the video to make a change like that, but next video I make, it'll be set up and ready to go. Okay, so there we go. Here's where we can see in I think this is in AWS. I'm not sure. ECS cluster with running Fargate container. Inspect the CloudWatch dashboards for Lambda duration, and DynamoDB consumed read and write capacity units, noting that latency looks good. All right. So Lambda duration, let's note that latency looks good. I don't know how to do that. So I don't even see latency on here. So this is Dynamo consumed read and write capacity units. I don't see anything about latency. Increase the Fargate container count to 5 in the file. So there we go, changing this value. Redeploy the CDK-Fargate stack. Okay, so CDK deploy is the command for that. Inspect the CloudWatch dashboards for Lambda duration and DynamoDB consumed read and write capacity units. There we go, doing that. This looks like the same. Oh, you know what? It is the same graph, but there are going to be changes to the graph that are meaningful. Both DynamoDB read capacity units and Lambda duration metrics increased as expected because we are now simulating 5 times 10 equals 50 concurrent users. To simulate more users, we can both increase the concurrency value in the torus.yaml configuration file and increase the desired _count for the Fargate containers. Between these two values, we can easily increase the load on our REST API endpoints. Delete the CDK stacks. So CDK destroy is the command for that. It is worth noting that the serverless architecture we deployed, API gateway plus 5 Lambda functions plus DynamoDB table, turned out to be a good fit for our CRUD REST API application. We also followed best practices and defined all our infrastructure in Python code by using the AWS CDK. So here's some exercises. We can make a simple HTTP endpoint using a Google service, Cloud Run. I'm going to move my bookmark forward and then click that. All right, so we can do it for free. New customers get free credits, and you're not charged for your free credits. So it probably does involve giving over credit card information because, of course, it does. So here's my account information for my private account here. So I will click agree and continue. And here's payment information. So not good with that. I don't think it showed any private information. Well, I know that it did show a little bit, but it's deep into the video and it was basically nothing. So yeah, I'm just kind of backing away from that slowly and not continuing with that. So we could run it here based on Kubernetes. We could install Apache OpenWhisk inside a production grade Kubernetes cluster, such as Amazon EKS, Google GKE, or Azure AKS. And then finally, we could port the AWS REST API example to GCP and Azure. GCP offers cloud endpoints to manage multiple APIs. Similarly, Azure offers API management. So we could do all that. But I'm just so paranoid about getting charged. And then not only that, hey, look at chapter 14, ML ops and machine learning engineering. Let's get to that. Let's stop wasting our time with a tutorial that I can't get off the ground and that I'm worried will cost me a significant amount of money. And let's read about this because this looks awesome. So that's the end of this video. Stay tuned for the next chapter, which is ML ops and machine learning engineering. Sounds good to me.